Okay, good afternoon, students. Uh, I hope you are able to hear me. Uh, Last week, I had discussed some points about philosophy and ethics, and this was something like a primer on philosophy and ethics, just enough for you to have enough tools to deal with the rest of the lectures, just enough grounding in philosophy which is required for you to understand what ethics and philosophy in science and research is all about. So in this lecture, I'll be going ahead. Probably I'll just recap the last two slides which I had shown you earlier. And before I start, again, I would like to inform you that you have my email address here. In case anyone of you wish to ask me anything or have anything to discuss, you're most welcome to drop an email. And or you can also put your questions in the chat box, and I'll try my best to answer your questions. Okay, so now we move on with today's lecture. So as I said, I would be recapping last two slides, which I had shown last time, my last lecture. Okay, so that last part of my lecture was concerning ethics in science and research. Yeah. So the question I had asked was, do we really need ethics in scientific research? And I had talked about the philosopher Plato, who lived 2,500 years ago, who equated virtue with knowledge and many other, at least three other major virtues. So he was the one who first stated that to be virtuous is to know the good, which is changeless, immaterial, transcendent, and absolute. So if ethics are based on hard facts, then why should there be so much disagreement about what is ethical and what is not ethical? The general tendency among scientists of the day is that they believe that science is, since it is subjective, there are no significant ethical issues in this area. Another viewpoint is that scientists do not require any formal grounding in ethics, as it was believed that one learns ethics while very young. In a way, it's true, of course, we do learn ethics when we are young, because when we are very young, our parents teach us what is right and what is wrong, things like that. And also, if a person is considered ethical at the beginning of, say, a scientific career or any other career, he or she would continue being ethical. So these are viewpoints which are rather misguided. And if you look at the present-day research environment, it is quite prone to problems, and you need constant course corrections all along the way. And because of these reasons, for many of our young scientists, research scholars, research has become a big minefield of ethical issues. So it is really essential that all of you should make yourself aware of serious ethical issues that you would have to confront at some point of time in your careers, or even at some points of time in your careers. And as I know everyone says, it is never too late to learn anything. So here it's never too late to learn about ethical issues. Okay, so now if you look at how research is done these days as compared to the historic era, in the olden days, scientific research was mostly an individualistic uh, hobby or pursuance. So, like an individuals were driven by personal interest in the field. So, you look at the age-old scientists like Galileo, Copernicus, Giordano Bruno, our own philosophers, Bauddhayan, Aryabhat. All these people, they work on their own without any significant contribution from, in any manner, from others. But of course, going ahead a little from those points of time, we could see that there were some elements of organized research activity in the form of some universities, very few of them of those times, which were basically rather supported either by the royalty or mostly by religious centers. And that's the reason that you could see that most of the scientific research which used to be carried out in those days had a heavy element of religious, in quotes, interference. But the present day research is very much different. It's very much an organized activity in which quite large groups of people participate, and they are supported and regulated to a large extent by the governments of different countries. So now how does this come about? One major feature, as I said, is our present day's research activity. It requires very large funding, mainly because of the high component of technology involved and many other things like human resources, which all cost a lot of money. So this kind of sophisticated equipment, advanced technologies, they really cost a lot of money. So it's really impossible for an individual in these days to go and do research without any component of public funding or governmental funding. So these days, resources for scientific research largely come from government agencies. They also come from business houses and industry, and to some minor extent from some social organizations. Now, again, there's just one pot of gold where everyone aspires to have put their hands inside and get something out of it. So this kind of a mad scramble for funding has given rise to a number of ethical issues. And also, since scientific activity is also funded by business houses and industries these days, there is an interdependence of research with business houses, and this has given rise to different kind of ethical issues concerning scientific values and so-called business ethics. In my view, there's no such thing as business ethics. It's an oxymoron. Because the business house always looks for a profitable running of the business. So it is expected that scientific research is carried solely for the benefit of humanity, but the rate at which science and technology is advancing, it can sometimes displace ethics and also move the ethical goalposts from time to time. You see, the public usually expects a lot from scientists. Scientists are usually held on a higher pedestal by the general public. So the general public expect a lot of something like miracles from scientists all the time. So it is behoven on part of the scientists that they should not try to do anything that could erode that public trust and public expectations. Of course, these are quite high, but scientists must always keep in mind that, look, uh, whatever funding your scientists are getting is mainly because of the government contribution, which indirectly means a public contribution in the form of taxpayers' money. So this is a point which one should keep in mind when you start doing scientific research. So I mentioned about business houses. So when business houses support scientific research in any manner, they don't do it for charity or just for the benefit of all mankind. They have their own interests involved there. Okay. So, of course, sometimes business houses, they themselves have their own scientific research activities, their own laboratories, but by and large, business houses will have to depend on other academic institutions and scientists who are working in these academic institutions and organizations, government organizations, for their research components. So then, how does these two diagonally opposite things can work together? So there are issues like ethical issues which can arise when the scientist is suppose working at an academic institution. So you can have problems when it comes to sharing of credits, intellectual property rights. Of course, there will be a whole series of lectures on this subject after my series of lectures is over. And then ownership of the knowledge which is generated from those kind of projects and patents and things like that. So there is going to be quite a big problem on who gets what, or who is the owner of the new knowledge which should have been generated from an activity funded by a business house and industry. And of course, scientists who are working at universities, so they have to strike a balance between teaching and research, and they tend to neglect teaching sometimes because of some undue pressure from the business house or the industry. And this is not like either by the teaching community, the university, or the students, all will suffer. And also the government funding agencies, they just don't want businesses to profit from publicly funded research. So these are some tough questions which there is no straight answer. There are no straight answers. So each case has to be considered independently, and then the proper ethical standards have to be worked out for each such instance of a cooperation between a business house and an academic institution. Okay, so now we move on to the main course part of the lecture series, where we discuss certain things like what I call as ethical flashpoints. So these are a list of subjects which I have put down here, which I will call as ethical flashpoints. The first is intellectual honesty and research integrity. Then whatever comes later are mostly the antithesis of intellectual honesty and research integrity. So we have scientific misconducts like fabrication, falsification, and plagiarism, then redundant publications, selective reporting, data misrepresentation, ethical issues and ethical committees, and moving on to publications, publication ethics. So what are the guidelines one has to follow? What are conflicts of interest? Then publication misconduct. This is a fairly common occurrence with almost, you can see in all countries this happens. And sometimes it happens intentionally, sometimes it happens unintentionally. So you have here what are called authorship issues, then complaints and appeals, how you undertake complaints and appeals when you come across publication misconducts. Then this issue of predatory journals and publishers, which I had talked about in my last lecture. So we start with the first topic, which is intellectual honesty and research integrity. So research is normally defined as the pursuit of truth. Okay, and how is this pursuit of truth carried out? It is done in an objective and unprejudiced or unbiased manner. So it is a quality of, it should be a quality of all scientists that they must be unprejudiced, they must be objective and truthful in all aspects of the research process. So in the last series of lectures on research methodology, you must have been informed about several ways in which you undertake research, the methods of research. Now, in all these aspects, the research methodology, then dealing with people, dealing with science subjects, in all these aspects, okay, one has to be unprejudiced, objective, and truthful all the time. So this has to be an underlying cardinal principle at all times. So what it means is that there cannot be any room for instances of fabrication, falsification, or misrepresentation of data or results. Then honesty also actually promotes cooperation and trust. And any absence of honesty would simply destroy this trust. And a destruction of trust would be actually detrimental to the scientific goals which you set out to achieve. This cooperation is one thing which is really vital whenever you undertake scientific activity, because, as I said, nowadays research is a very organized activity. You deal with a lot of people, and you deal with different kinds of people also. So it is really essential that, number one, there has to be cooperation, and number two, there has to be a lot of trust. If you're not trustful of each other in a scientific activity, that spells doom for that kind of activity. So, yeah, as I said, research is a pursuit of truth in an objective and unprejudiced manner. So how do you say that? This is a very nice slide which I have taken from another author, Rasmussen from University of North Carolina. So what is this pursuit of truth? You have the very familiar saying, the truth, the whole truth, and nothing but truth. So what does the first word mean, the truth? So you have to be fully honest about your research. And what do you mean by saying the whole truth? Here, what it means is that in a research activity which you are undertaken, and if you happen to omit certain parts of your research findings, this can actually constitute a research misconduct, or it could violate other moral norms. So it is essential that you present the whole truth as it is and not try to hide certain aspects of your research findings, probably which you may find incompatible with, say, the hypothesis which you have started off with. And then finally, we have nothing but the truth. And then what do you mean by this? So there's a general tendency that, especially when people, scientists, they like to publish the results, they get into some trouble with the referees, etc. Or in order not to get into trouble with the referees, they try to exaggerate the results by adding certain misleading information or trying to overstate the significance of the results. So basically, what I call it is just beating around the bush. So this again is a sign of dishonesty, and one should not try to present anything other than the truth from your scientific uh, activity. So it is dishonest to exaggerate one's results by adding misleading information or overstating their significance. So to whom do we owe this truth and why? First of all, as I said earlier, the public. Okay. The public, in the form of taxes, they pay a lot of money to the government, which in turn uses part of that money to fund research activity. So the public, we owe the public the truth because the funding you get for your research is to the public. Then the individual research participants in your research activity, one should respect their autonomy. And when I say autonomy, it could be subjects of your research, it could be in the form of human beings or your colleagues. So you owe the truth to all your colleagues and collaborators, whose research again may be based on your present research. So that means when you publish certain research findings, there will be people who will be looking at this research finding and then planning their own research activity with this as a starting point. So it is essential that you be truthful in presenting your present findings. Otherwise, if you present some false data, then that can go ahead and propagate because people are trying to look for those kind of things in their own research. Then the funding institutions who give us the funding for research, we are quite beholden to them. And then the research institutions and universities who employ the scientists, okay, who give the resources to the scientific, the laboratory space, funding for the instruments, students, etc. So one has to be grateful to the scientific institutes and universities for giving us all the facilities to carry out the research. And mind you, if you do some kind of a scientific misconduct, and because of your misconduct, it's not only you who's going to get affected, but the institution to which you belong also gets affected by what the scientific misconduct which you have done. So all these obligations of research basically stem from its nature as the pursuit of truth and knowledge. So there are certain, again, do's and don'ts. Should not allow one's personal biases to interfere with the pursuit of truth. Okay? Because when you set out to do a scientific research problem, you may have a certain personal bias, either in carrying out a particular way of doing your experiment or keeping some records or some way of keeping records, etc., which could be other than the standard laid out procedure for that particular activity. So if you have a difference of opinion, you should not let that interfere with the basic standard procedure which has been laid out, which I believe is for pursuit of the truth. Then no intentional omitting of relevant facts. This is again a very, very important issue. Probably some of you must have heard of the Millikan oil drop experiment right from your BSc onwards. It is well known that in the of course, Millikan was awarded the Nobel Prize also. So during the experiments which Millikan had carried out, he has done it with his student. In fact, it was a student who first suggested to Millikan that one can use oil drops rather than water, which was done earlier and that had failed. So when the student suggested that one could use oil drop for the experiments, so Millikan used that oil drop and of course succeeded. But then of course in a given number of experimental trials, only some of them were actually successful and some of them were not successful. But when Millikan actually presented the data, he presented only the successful parts of the experiment, which was, I would say, unethical on the part of Millikan. But then, of course, there were no such kind of checks to know these things in those days. And whatever happened has happened. And of course, Millikan was also awarded the Nobel Prize. Then, presentation of facts in an unbiased and untwisted manner. So again, this is somewhat related to the previous point again. But then one should try to present the experimental findings without bringing in your own personal biases or any other biases into the picture. And also, you should not try to twist the results to, say, mold them to suit your hypothesis or things like that. Then we have credit issue. One must give proper credit whenever it's due. And of course, you don't have to give credit when it's not due. Fine. But whenever it is due, we have to give the proper credit to whoever who deserves it and avoid plagiarism. So these two issues are a big problem, which I will be trying to discuss more and more lectures ahead. So this giving of credit is something which bugs a lot of people, and also the plagiarism issue. Then one has to properly acknowledge and attribute previous research works which are relevant to the present research work which you are undertaking. And whenever you write up your papers or publications, one has to refer to these previous works in a proper and correct manner. Because if you find that your results actually, some previous work has a bearing on your present results, and if you do not refer to that previous work, actually it's a it's a kind of a misdemeanor, because you're denying the credit which was due earlier to the person who has already done that work and showed you the path on how to do your research work, thereby denying him that kind of a credit or a citation. Okay. So this again, we find this happens quite often in research activity all over the world. And this happens mainly because, again, of personal biases which interfere with your thinking at this point of the issue. This point of the, whenever you have to acknowledge previous works, so this kind of a bias can creep in. And one should guard against that, because at some point of time, you may get away maybe once or twice, but at some point of time, it's going to hit you, and then it will boomerang on your own research work. And I'll try to show you some instances where this actually has happened, and how people either had to retract their publications, or again in an erratum or something or an addendum, give a proper credit to a previous work. So this happens all the time. So if everyone were honest and truthful about the research work they're doing, this may not arise at all. But then that's a little difficult to ask for as 100%. Okay. So regarding the credit part, I'm just showing you an editorial which happened to be published in the this popular physics journal, which is Physical Review Letters. So Martin Bloom was at that time, this I think was in 2004, he was the editor-in-chief, and they had a meeting on this credit issue, and the American Physics APS Council, they had a meeting and then approved this following guideline on references in publications in their journals. So I'll just read out this. It's a very nice statement which they have put out. Authors have an obligation to their colleagues and the physics community to include a set of references that communicates the precedents, sources, and context of the reported work. Proper referencing gives credit to those whose research has informed or led to the work in question, helps to avoid duplication of effort, and increases the value of a paper by guiding the reader to related materials. It is the responsibility of authors to have surveyed prior work in the area and to include relevant references. Proper and complete referencing is an essential part of any physics research publication. Deliberate omission, underline, you can see this word, deliberate omission of a pertinent author or reference is unethical and unacceptable. So this is the last line is the clincher. Deliberate omission, which happens, I would say, quite often. It is really unethical and unacceptable. So continuing, the quality of referencing must be a responsibility primarily of authors, but also of referees. That means what he is trying to say is not only authors are responsible, even the referees of the journal who are looking at this submission of this manuscript, they should also be aware of this fact, and it's partly their responsibility also. So also of the referees, as all should be aware of pertinent previous work. Citations should be as complete and up to date as possible and can be drawn from e-print archives as well as peer-reviewed journals. Now you see how difficult even a referee's job is. Authors may be tempted to cite review articles and references contained therein, when a more judicious selection of citations is fairer to those whose work has motivated the paper in question. What is the meaning of this line? I'll tell you, but it has happened to me also, of course. See, when you try to write a manuscript and you want to refer, I mean, you have to refer to, say, a certain previous research work, but somehow, maybe because of your bias or something, you do not want to refer to that previous work. There is a recourse possible. What is that? Suppose if that previous work has been cited in some other later review, which has happened before your manuscript, you can simply cite that particular review and say references contained therein, which means that even the original reference which you wanted to, which you should have given, is also included in that review. But what is happening is that the primary author whose work you are trying to comment on or work on or whatever, is not being cited here. So this is the meaning of this statement. So this is again a dishonest thing to do. So one should be careful about it, and then you must try to judiciously select the citation which makes it fair to the person whose work has actually motivated your research work. So we ask the referees to include the adequacy of references in their assessments and authors to respond when missing references are noted. Then they go on to say, we realize that one cannot know everything. Claims of novelty, which we discourage, are sometimes shown to be confirmations of previous work of which the authors were unaware. It is not unethical to omit a reference accidentally or in ignorance, provided that a prompt correction is made. If a paper is close to publication and is found to lack an important reference, a note of acknowledgement can be added in the conclusion, saying after publication, a simple erratum, rather a comment, can also suffice. Then failure to reference can cross the line to plagiarism when a deliberate omission creates an impression that authors of the later paper conducted the research reported in the omitted reference. So that means it conveys that basically that you were the first person to carry out this research rather than the person whose previous work which you should have actually cited. So this and other equally serious matters are addressed in the APS guidelines for professional conduct. So I encourage all of you to look at these APS guidelines for professional conduct. Ideally, more diligent searches, broad reading, consultation, and generous referencing can head off most of these problems before submission. Signed by Martin Bloom. So this was a very wonderful statement which he has made, editorial which he had written way back in 2004. And so there are certain instances, examples which I'll be talking about in these series of lectures. So now we come to the second part of that subject, which is academic or research integrity. So again, the Council of the European Union has specified this definition for research integrity. They say that research integrity relates to the performance of research to the highest standards of professionalism and rigor, and to the accuracy and truth of the research record in public. Good research practice includes research ethics in the proposal as well as the experimentation phase, as well as publication ethics in its analysis and dissemination. So the way research is conducted must allow others to have confidence and trust in the methodology which was followed and the results which had emanated from the research work. So this relates not only to the scientific integrity of the research work, but also it refers to the professional integrity of the scientist himself. So this has two parts to it. So when you say scientific integrity, it refers to the integrity of the research work which you have carried out, and professional integrity refers to the personal integrity of the research scientists. So both of these qualities matter. Okay, then how should we devise an ethical framework for scientific research that could be carried out based on, say, model principles and science? So when you say an ethical framework of certain principles, so what should they do? They should basically promote advancement of scientific goals, lead to, say, betterment of the society and things like that. And what could be these set of basic moral principles? So here we have honesty, carefulness, openness. So let us see how this would affect or help you in your research, being honest about your research. Honesty. See, again, what is the antithesis of this? Scientists should not fabricate data, falsify the results, or try to misrepresent data or the results. So there should be an objective and unprejudiced and truthful representation in all aspects of the research process. So this is one way of talking about honesty. So what happens when you are dishonest? So dishonesty or errors. See, there could be a problem with your research work because of errors also. And sometimes these errors, they could be unintentional. If the errors are unintentional, then it's not dishonest. So you need to distinguish between genuine errors and being dishonest. Okay. So a dishonest act, for example, it always involves the either intent to deceive the reader or the people who are participating in the research, others who are participating in the research, or your colleagues. So, for example, if you have a dishonest way of doing certain things, okay, then what happens is that the audience which is going to look at your result, they are there with the expectation that you're always going to say the truth. But when you put in something through a dishonest means, that can again percolate down, and people who are looking at your publication, they may feel that that is correct and then go on in the same direction. And they may never achieve, if he is honest, if the person is honest, he may not achieve the right result which he is trying to look for, because you have achieved the result through a dishonest way. Okay. So some honest, unintentional errors, they'll be forgotten by people. But then once if you do certain dishonest things, lies, etc., that nobody will condone and nobody will forgive. Then the second aspect is being careful about your research. So it's always useful whenever you carry out the research as per the research methodology which you have adopted, the various aspects of the research methodology. In each of these aspects, one has to be careful about these aspects. Okay, and people should try to avoid errors in research, and especially when you present the results. And you should try to minimize these experimental or methodological or human errors as much as possible when you try to carry out your research activity. And things like self-deception, bias, and conflicts of interest must be avoided at all means. So suppose when you read a paper in a reputed journal, you normally tend to assume that the research is valid. But if the particular research which you have referred is not valid, it could lead to an incredible waste of time for those who will be doing a follow-up of that particular problem. I try to give a very small example how a carelessness in doing a research problem can lead to certain problems, certain issues. I'll just show you one, sorry. Yeah, this was a paper which appeared in 1997. In 1997 to 2004 or 5, they were the heydays of what are called this giant magnetoresistant problems. And the manganites, which were a very popular, which are still a popular class of compounds. For those of you who are in physics will know about this. There was a lot of research activity involving manganites because they promised a lot of advancement in technology. So there was a paper which appeared on what is called a double-layered manganite. Okay, normal formula for a manganite would be AbO3. Okay, this is called a single layer perovskite. There are certain categories of compounds which go into several layers, where we have what is called a double layer manganite. It's also called a Radolfson Popper phase with n equal to 2, where we have this structure which is A3B2O7 type of structure as compared to AbO3. Okay, So we had this A3B2O7 type of structure, which suddenly one publication came with this particular compound here, this compound, promising a lot of advancement from what was the state of art at that point of time. And this was what is called a rapid communication in the journal Physical Review B. So they published initially, they said that they have synthesized this compound and published an X-ray diffraction pattern. So this, what you see, is the X-ray diffraction pattern. I suppose most of you know what is an X-ray diffraction pattern. So it is basically, it shows you the fingerprint of the structure of a particular compound, okay, or the lattice structure of a particular compound. So that is the fingerprint of that compound, which is called X-ray diffraction pattern. And what the numbers you see here are the indices, where each Bragg plane, or what it's called, it gives a certain index which conforms, of course, to the type of structure you're dealing with. So they put out this X-ray diffraction pattern and also indexed it by using these indices, which conforms to this I4 by mm crystalline space group. Then me and my collaborators at that point of time, we felt also that this is a promising field of research, and one should try to look at something deeper into this kind of material. So we set out and tried to synthesize the same compound initially, and we made this compound. And after we made this compound, we compared our X-ray diffraction pattern with this pattern. It was almost identical. Then, of course, we tried to analyze this pattern, but then we found that we could not analyze our diffraction pattern in terms of this particular structure. So we tried our best. Okay, if you look at this circled points, okay, so that happens to be the 101 reflection. It is a vital reflection for conforming to this particular space group. But then we found something small and minor issue with this figure over here. There was a very small, you can see a small peak there. One can easily mistake this for some noise in the pattern. Okay, we thought that there was a small peak here. So then we saw that why this person has not tried to index this. And when we also tried to index our own diffraction pattern, this particular peak was not indexable at all. So you could see that this was our sample which we synthesized, very identical to the published data. And we tried our best to fit it by using a certain statistical technique, which is called the Rietveld analysis of powder diffraction data, which is almost like a foolproof analysis of diffraction data, where you have the raw data and then you also have a theoretical calculated pattern, and you try to fit it with that theoretical pattern. We could see under no circumstance that we could fit this bottom curve here shows the difference pattern between the fit and the data point. The fit you can't see, the line you can see through the data point is the fit. So there was no way that you could fit this particular line, nor there were certain peaks which are shown as stars. They were not indexable at all in this particular structure which was shown to you earlier, this I4 by MMM structure. Okay, this one. So it was just not possible to fit it with this. Then we were trying to break our heads, and then we went back to this original data itself. We used a digitizer to digitize this data, and then we tried to redraw this particular, get the data points from this published data by digitizing it, and then fitting their own data with their own structure and lattice parameters. It turned out that it was just not possible to fit even this data itself with the proposed structure in that paper. Then we realized that there could be an issue here, then we simply try to fit it with an ABO3 system, which is basically LaCaMnO3, and then we added an impurity. Because whenever you deal with lanthanum oxide, which is a starting compound for this material, it usually disintegrates, and then sometimes you can have a compound which doesn't form at all. And in this particular case, we found that this particular compound, which the authors had proposed, this does not form at all in nature under normal synthesis techniques. So that was the result which came out. And then, of course, we had a tough time trying to get our comment published, because the editor himself was trying to say that, look, you have not worked on the sample which was published earlier, and you have your own sample, which could be a problem. But then we tried to reason, and then finally we won the case, and then we could show that whatever was published earlier by the earlier author, it was just not that compound at all, but it was just a compound of the type ABO3 with some impurity which had come out in the process, which is calcium oxide here. So now you can see it's a beautiful fit without any problem. And then, of course, once this comment was published, there was an instant stop to all the activity based on this composition. So that gave us a personal satisfaction that we were able to stop certain category of compounds which was not simply possible to synthesize. And I could, in my own experience, I could also, I knew one PhD student was quite close to me who was working on the same kind of compound. He, of course, he had to stop his that particular problem and choose some other problem. It was fortunate because we could check this well in time. So that was a case of carelessness. And once we sent our comment, the original authors, they realized the problem which they were in. They tried their best to avoid refuting our comment. Finally, they had no answer, and this comment was published without any reply. So that is the thing which you need to worry about, carelessness. Then openness in research. See, openness is something which also, again, one has to be careful about. See, whenever you do certain research, you need to be open about it. You should be willing to share the data results. You see, in the earlier case which I showed, if the authors were only willing to share their data, could have easily finished the problem then itself. But they were not willing to share the data. So you should be open about it, willing to share data, results, the methods which you have adopted for your research work, the methodology, and then the ideas and the techniques, sorry, and the tools that you have used for your research work. Okay, so other scientists who are following your research work, they should be in a position to review their own research work, and then one should be open to this kind of criticism and also new ideas which are coming in from subsequent people. Then we have freedom, credit, and education. So here, scientists must be free to conduct their research work, okay, on any problem or given hypothesis. You see, all these points actually, you should follow this book written by David Resnick, Ethics of Science. It's a very beautiful book, which I would recommend all research scholars to read. It's a very, very useful work. I'm sure you'll find it very useful. So now, freedom is a certain issue where even down the ages, we had a lot of problem with this particular principle. You look at, say, Galileo Galilei. he invented the telescope and started looking at all the stars, and then started putting out his hypothesis. It was not liked by the rulers at that point of time. It was not liked by the religious people at that time. So he had to bear a punishment for that. He was imprisoned for the rest of his life. But there was another person before that, Giordano Bruno, who also proposed this heliocentric theory. And he, of course, at that point of time, he was very unlucky. He was simply imprisoned, not only imprisoned, but also killed. He was burned at the stake alive because he proposed these ideas of heliocentrism. So you see how freedom matters here. It really plays an important role in dissemination of knowledge and also expansion of knowledge by allowing scientists to pursue new ideas and then work on new problems and in turn help the society. So freedom is quite crucial, but you can take it for granted there will be certain restrictions, but of course they will be minor in nature. Why? Because again, as I said earlier, funding is not your own funding. There's someone else funding your research, so they will have their own restrictions on how the money is to be used. Okay, and then sometimes you may not be allowed to do experiments in a certain manner on certain living things. You can do experiments on animals. You may also do experiments, especially in medical field, on human beings. So here, again, it's not your entire freedom. You are not entirely free to do whatever you want. There are certain restrictions, which we'll go into a little later, based on ethics and ethical committees. Okay. One very nice example here is that of a Russian scientist called Lysenko. So there was a field called Lysenkoism. I mean, this one attribute. This happened in the Stalin era. So this guy, Lysenko, he simply went against the principles of Mendelian genetics and proposed his own theory of genetics. And because he was very powerful in the political situation at that time, he could simply put a stop to all other viewpoints in the field of genetics in Russia at that point. And in fact, there was a huge purge of geneticists in Russia in those days, and some were also killed. So this put a huge setback to the Russian program on genetics by several years. So one has to have freedom in doing research, of course, subject to certain minor restrictions. Then credit, I have also already talked about credit, so I'll not go into detail again. But then there are certain correction mechanisms here. That means if you don't give credit to the way it has to be given or wherever it is due, then there has to be a punishment there in certain manner. And then again, credit also is important when a publication turns out to be a flawed publication. So whenever there's a publication which is full of mistakes, then the credits part will help in fixing the responsibility on who was at fault with that particular kind of paper. Then education, of course, one should do a lot of education, because this, as a scientist, it's your duty to educate students, educate the public, and educate other scientists. And one can do this either mentoring students, by way of mentoring students, or by way of giving talks, popular talks to the public, popular articles in books, etc., lectures. And so this is a very important aspect. And then we have what is called social responsibility. And again, scientists have a very big social responsibility, and as I stated earlier, because scientists must also be responsible for the consequences of their scientific research. And so they have a certain social obligation here. So if they find that the particular science activity which they are following is detrimental to the society, then of course they should make the rest of the public aware of this issue and what could be the consequences of the scientific activity. So there is a certain social responsibility in science, and it promotes also public support for science in turn. And then we have legality. So legality is again another thing where scientists have a moral responsibility to obey the law. Okay. Again, in different countries, different laws operate, and then whenever you work with hazardous materials, there are certain laws which scientists have to obey, or restricted materials. Again, scientists have to obey those certain laws. Then, when you work with animals or human beings, for example, cruelty to animals, there are certain laws which prevent scientists from being cruel to animals. And then these are the moral kind of issues. But then you have also another kind of moral issue, which is ethical issue, which is misappropriation of funds. This is another problem which sometimes rears its head in the scientific community. I can tell you an example. Of course, I don't want to take any names here. A very famous research institute in the country, a very big professor, and he happened to become the vice chancellor at a particular university in the country. And while he was the vice chancellor, he undertook certain very unethical practices for which, in fact, he was finally arrested at the end of his term. So misappropriation of funds is another big problem. Scientists have to be really careful about this, and one should try to avoid this as much as possible. And then opportunities. So again, scientists should not be unfairly denied opportunities for scientific research or to use scientific resources. And again, one example I can give you here is that very often, not only in our country, but in many other countries also, it so happens that prestigious labs and very large scale scientific projects, they corner all the money, almost the major chunk of the funding. What happens in this process is that scientists from smaller bylines with smaller research projects, they are often denied research funding because there's no money left, or people even don't even look at these smaller bylines. So this is again denying or denial of proper opportunity to everyone. Another area is women and minorities. So in fact, it is heartening to note that the Department of Science and Technology in the country, it has a Science and Engineering Research Board. It has come out with a new scheme called POWER, P-O-W-E-R. It means promoting opportunities for women in exploratory research. So this is a women empowerment scheme which has been floated by the Department of Science and Technology. So this comes under this category of opportunity. Then finally, we have mutual respect, efficiency, and respect for participating subjects. Mutual respect, I had already talked about. One has to cooperate with your colleagues. One has to have a mutual respect towards each other, because if you don't have this kind of respect, the trust between the two breaks down, which is not good for the scientific endeavor. And then efficiency. So one has to be really prudent about using your resources. Okay. So the resources could be financial, could be human, or even technological resources. So you have to make sure that all the resources are efficiently managed. But inefficient usage of these resources would again lead to various issues. Okay. Then respect for the subjects, which I already talked about. Whenever you have living beings participating in research activity, one should respect their autonomy also. So that is a very, you cannot violate their autonomy, and so basic human rights and dignities cannot be violated. So I think probably I'll stop at this point. So in the next lecture, I'll be dealing with scientific misconducts, where we have falsification, fabrication, falsification, and plagiarism. So that will be the subject of my next lecture. So thank you for your attention. And if you have any questions at this point of time in the chat box, etc., I can try to answer. Does scientific misconduct considers both intentional and unintentional violation as same? And is there any law against people who does scientific misconduct? Very good doubt. Just a moment. Yeah, and now you talked about intentional misconduct. Intentional misconduct, of course, there are no laws against this. You see, in this game, there are no laws. Basically, when laws are only for things like financial misappropriation and things like that, which I just mentioned a few minutes ago. But scientific misconduct, where it involves falsification of data, fabrication of data, and plagiarism, here the only worst thing which can happen is retraction of a manuscript, and then we have what is called name and shame. So these are the sentences for that kind of misconduct. But when there is an unintentional scientific misconduct, all it requires is an acknowledgement that the mistake which has been made was unintentional, and a proper erratum which should be published after this particular publication was already published. There should be an erratum which should come in a later publication, which highlights that there were certain unintentional mistakes which had occurred. Now, if the unintentional mistake does not have a major bearing on the results of the publication, then just a small erratum is okay. But if that unintentional error actually completely puts your scientific work into question, then you may have to retract that publication. Okay. Then if a journal has limit for references, and we have many references, how we decide on what to cite and what to ignore? This again here, the first person who crosses the line. Okay, suppose you're trying to refer to an earlier work. Again, in the set of earlier works, you'll have one person who predates all the other earlier works, earlier references. So if you have a problem in trying to limit the number of references, then probably you give the first person who proposed whatever problem, etc., and give that particular reference, and you may have to try to cut down certain other references. And in fact, if there happens to be a limit, or if the journal feels, the editor feels that a subsequent reference also needs to be included, then they will take care of it, and you can simply include that particular, cite that particular reference also. So you have to make always this kind of judgment. So who is the first person who proposed that particular problem? Or if you have a certain references, which was the first guy to cross the mark? So you take that one, include that, or the first few, and ignore the rest. Okay, that's one way of it. Any other questions? I guess not. So thank you for your time. And we'll come back next week next Wednesday with scientific misconduct, where probably I can talk about these issues more in detail. Thank you very much.